In this video, we're going to learn how to use the Pythagoras theorem to find the hypotenuse of a triangle, and then we're also going to look at Pythagorean triples. So you might recall from yesterday that we discovered Pythagoras' theorem. We also found out that the hypotenuse is the longest length in a right angle triangle, and the hypotenuse can be found opposite the right angle. We also discovered the formula for Pythagoras' theorem, which is the hypotenuse squared is equal to the sum of the squares of the two shorter sides. So, the first task today is to identify the hypotenuse. So a reminder, this is opposite the right angle. So just now would be a good time to pause the video and go and work these 7 triangles out and identify the hypotenuse in each. Okay folks, so hopefully you got on well with that. So if we look at the first one, the red triangle, we've got x, y and z, and hopefully you've realised that z is opposite the right angle, so that means z is the hypotenuse. For the orange triangle, opposite the right angle is D. In the purple triangle, we have U. And the yellow one is the star. The light blue one is A. Dark blue is G. And the green is B. So now we know how to identify the hypotenuse in any triangle, any right angle triangle, given it doesn't matter which way it's positioned, it can be rotated. We still look for the hypotenuse across from the right angle. So let's see how to use Pythagoras' theorem to find the hypotenuse. So example 1, you can see here we've got a right angle triangle with lengths 6, x and 7. And if we have a wee look at this, we can see firstly it's got a right angle. So it is a right angle triangle, so that allows us to use Pythagoras' theorem. So the hypotenuse squared is equal to one of the other sides squared plus the other side squared. So we can see here that our hypotenuse is x. So we can substitute that in for h. So x squared is equal to 6 squared plus 7 squared. Now, if we keep going with this, we know that 6 squared plus 7 squared is 85. So x squared is equal to 85. Now, we need to know what x is on its own, and currently x is being squared, so the opposite of squaring something is square rooting it. So we have this, square root of x squared is equal to the square root of 85, and the square root of x squared leaves us with x, and the square root of 85 is 9.22. We're working in centimetres, and we've rounded that to 2 decimal places. So just now would be a good time to pause the video and copy this down in your notes jotter. Okay, let's look at another example, folks. So we've got example 2. We've got a triangle with lengths y, 1.2 metres and 0.5 metres. So again, the first observation needs to be whether it's a right angle triangle or not. So here it is, so that means we can use Pythagoras' theorem. So Pythagoras states that the hypotenuse squared is equal to the sum of the squares of the other two sides. And we can see here that our hypotenuse is y. So instead of h squared, we're going to have y squared. and y squared is equal to 1.2 squared plus 0.5 squared. Now we can put that straight into our calculator. Always good to use our square button as well. So y squared is equal to 1.69. Now in order to get y on its own, instead of y squared, we need to square root both sides, leaving us with y being equal to 1.3 metres. So just now would be a good time to pause the video again and to copy down example 2 into your notes jotters. Okay folks, welcome back. So now we're going to have a wee quick look at Pythagorean triples. Now a Pythagorean triple is a triple, 3 positive numbers, positive integers, such that a right angled triangle can be formed using these integers as lengths. Okay, so basically we've got 3 whole numbers which can form a right angled triangle. Now you might have noticed in our 2 previous examples we had decimals for both of our answers, and this is quite common. So the thing about a Pythagorean triple is that they're positive whole numbers, positive integers. Now there are 16 primitive triples to start with. Now we can make more triples from these, but these are the sort of original ones, if you like. And the most common one that we see a lot is the 3, 4, 5 triangle. And it would be good if you learned this, if you remembered that if we've got 3 and 4 for the shorter sides, well, the hypotenuse is going to be 5. Or if you know the hypotenuse is 5 and one of the other sides is 3, then the other length will be 4, etc. Now another common one that we see a lot of is 5, 12 and 13. And the last one we see more commonly as well is 7, 24 and 25. So it would be good if the 3 highlighted ones here you copied down in your notes jotter and you memorise these, because even going through up to higher maths you'll still be using these Pythagorean triples, and it'll make life much faster at that point. So just now folks, you should have the 2 examples on the hypotenuse in your notes jotters, as well as the 3 Pythagorean triples that we've just talked about. And in your workbooks just now, you should go and try pages 3 through to 5. And you know that if you're stuck, you can ask me on Teams